Okay, here we are with an example of where we're searching for a specific antiderivative, so to speak, when we evaluate an indefinite integral. And so I did want to mention briefly, I did in last video, these formulas for the antiderivatives of exponential functions. We're going to be using those. I didn't want to give you an example early on because typically they're used with the method called substitution or the chain rule. So we're going to get into that later, as well as the antiderivative for 1 over x, which is a natural log of the absolute value of x. So, and the reason for doing that, obviously, is because the domain has to be a positive number for the natural log function. So, um, but anyway, I just wanted to briefly mention that. We'll get into that next video here. So, um, but as far as, like ones like these, we could use the formula here, but it's a little easier to understand if I talk about substitution at the same time. So I'm going to hold off on those. All right. So, this one here, like I said, we're looking for a specific antiderivative. Now, for this particular problem here, when we had the cost function, we found the derivative, we called that the marginal cost function. So that was just, I guess, a quote unquote economic term. Um, but really we're starting with the derivative here, okay? And so we want the cost function, which would just be C of X. So this is the derivative of the cost function, which again, we give it just a special name, the marginal cost function. And so what we want to do is essentially take the antiderivative of that particular one, okay, which is 6x minus 5 that was given to us over here. And when we do that, we get the antiderivative to be 3x squared minus 5x plus c. So again, we evaluated this indefinite integral. This is a family of functions. It represents, theoretically speaking, infinitely many, right? For as many constants there would be if there's no restriction. There could be this value can take on all real numbers, which would be a slightly different cost function, but they would be all the same family because when I would take the derivative of whatever this constant would be 0, and I'd end up with 6x minus 5. But we want the function where c of 0 is equal to 10. Okay, so we're looking for a specific antiderivative or a specific function here. Well, we call this with initial conditions, and let me try to pin that back again. So what we end up doing here is just taking that function, take c of 0, and we're going to replace the x's with zeros. Of course, we have our plus c, and that's equal to 10, and just algebraically solve for c. And we get that here. It is c of x is equal to 3x squared minus 5x plus 10. So if I take c of 0, I'm going to get 10. And that's what we wanted. Obviously, if I take the derivative of this, I end up back with the marginal cost function, which is 6x minus 5. Okay. So, again, one here that's maybe a little bit more involved with this. We end up with, and for some reason, this one's a little bit different here. I didn't write it on my paper, but they do give us the marginal cost function here. And notice it says 27 units cost $340. So all that really means is that C of 27 is equal to 340, which I wrote over here. Okay. So we're going to do the same thing as what we did up here. We got a little bit more involved in terms of the the exponent, or I'm sorry, the exponent being a rational number. But, again, no big deal. I just add 1 to 4/3, so, or to 1/3. So 1/3 plus 3/3, which is 1, is 4/3. Okay, so I get x to the 4/3. What do I have to multiply that by to get a coefficient of 1? Just the reciprocal, 3/4. This antiderivative of this term is just going to be 8x plus c. So now, again, the initial conditions over there, 27 units cost $340. In other words, c of 27 is 340. So I just substitute again the 27 in for everywhere I see an x and set it equal to 340 and solve for c. So without getting into all the details, you can do all this stuff on a calculator. It looks like writing's a little messy there, but I think it's 1,107. All this simplifies too, and then I just subtract that from both sides, and I, again, use a calculator here, and you get 253. divided by 4 equal to C. And therefore, my function over here is really, excuse me, what I have here, get back to that, okay, is just this value right here, okay? And so pretty straightforward, pretty simple. We're just adding in that step. And remember, all we're doing here, instead of dealing with a family of functions with an arbitrary C, we want a specific ones or a specific one with this characteristic. In other words, the cost of 27 units was $340. And so we just need to solve for the specific C to find our original cost function. Okay, because again, this represents infinitely many, and we want the one that has that characteristic. All right, so that wraps up that video, and we'll be back with the next one.